Hi dear students, this is me Ishfaq Riaz and today we'll be solving some numericals on dot product of the vectors. But before solving some numericals on the dot product of the vectors, if you let me remind you the things which we have discussed in the previous lecture regarding the dot product of vectors. We discussed the definition of the dot product of vectors, that is A dot B. Simply it is equal to AB cos theta. Right, and it is also called the scalar product of the vectors. Why? Because it always gives a scalar quantity. After discussing the definition of the dot product of the vectors, what we discussed was the geometrical interpretation of the dot product of the vectors. If you remember the concept of projection of A on B or projection of B on A, do you remember that? The geometrical interpretation of the dot product of the vectors. After this, we discussed a few properties of the dot product of the vectors. In the end, what we discussed was the applications of the dot product and the examples of the dot product of the vectors. And if you remember the applications of the dot product of the vectors, we are able to calculate the angle between the two vectors. We can calculate the work done by a force using the concept of the dot product. And today we will solve some numericals, we will solve some problems regarding the dot product of the vectors. So let me solve the numerical one here. The question is a force F and it is given in terms of its components. This is I in terms of unit vectors plus J plus K, and the SI unit of force is Newton. A force F produces a displacement of, let me write the displacement here, this is I plus J plus K, where this displacement is in meters. The question is a force F produces a displacement of I plus J plus K in terms of its meter, in terms of meters. So we have to calculate the work done this very force. We have to calculate the work done by this force, right? If you remember the applications of the dot product of the vectors, the expression for work in terms of the dot product is, it is given by F dot D, right? And I have already elaborated it, already explained it. How do we calculate the dot product of vectors in terms of its components? Simply you have to multiply the corresponding coefficients of I cap, J cap and K cap, right? So let me write here. So this is work done, that is given by dot product of force and the resulting displacement, right? So force के बदले में लिखूंगा, this is I plus J plus K. And I will take the dot product of this very force with the displacement vector, that is again given by I plus J plus K. This is basically the expression of displacement in terms of the rectangular coordinates, right? Okay, so if you remember, what is the coefficient of I cap here? It is basically 1I plus 1J plus 1K. Again here it is 1I plus 1J plus 1K. So I have to multiply the corresponding coefficient so as to get the dot product. So this is 1 plus, because I dot I is 1, J dot J is also equal to 1, K dot K is equal to 1, and the rest of the terms will vanish out. That is I dot J, it is equal to 0, right? So this is 1 plus this is 1 into 1, that is again equal to 1, plus 1 into 1, that is equal to 1. So if you take the sum of this, you will get 3. And this will be Newton meter, and you are already familiar with the SI unit of work, that is joule. So 3 joule will be the work done by this very force. So this is how do we calculate the work done by this very force using the concept of dot product of the vectors, right? Okay, now let me do the next question regarding work done. I mean regarding the dot product of the vectors. So let me solve next question regarding the dot product of the vectors, and let me read the questions from your text, or okay, let me read the question from your text. The question is a force F, okay, where force F is given by, it is 2I plus 3J plus 4K. A force F that is given by 2I plus 3J plus 4K displaces a body from position vector R1, where position vector R1 is given by, it is 2I plus 3J plus K. This is 2I plus 3J plus k. Okay, to position vector R2, where the position vector R2 is given by, this is I plus j plus k, right? Okay, find a work done by this force. A force F displaces a body from position vector R1 to position vector R2, that is given by I plus j plus k, right? So we have to calculate the work done by this force. If you remember the expression for work in terms of its position vectors, what we do, we basically calculate the displacement vector d by this very formula, that is given by R2 minus R1. And if you remember the expression for work, when the position vector is given, that is simply given by F dot of R2 minus R1. Right? Okay. Now let's try to calculate first R2 minus R1, that is the displacement vector. Right? Actually, the question is like this. This is point P, and a force F acts on this very point, and the position vector of this very point is R1, and the body is displaced from point P to point Q, right? Through a displacement D, the position vector of point Q is R2. So this displacement vector, it will be simply given by R2 minus R1 as per the triangle law of vector addition. So here, in this very case, the displacement vector will be R2. R2 के बदले लिखूंगा I plus J plus K. So this is minus R1. This is 2I, okay, plus 3J plus K, right? Now, this is basically the subtraction of the vectors in terms of its components, right? So the displacement vector R, this is I minus 2I, that is equal to minus I, plus J minus 3J, that is equal to minus 2J, plus K minus K, that will be equal to 0. So the displacement vector is simply minus I minus 2J, right? Now let's try to calculate the work done by this very force. So this will be simply given by F dot of D, where D is the resultant displacement, that is simply given by R2 minus R1. ठीक है ना? तो कैसे calculate करेंगे? So F, this is given by, so this is 2I plus 3J plus 4K, and I have to take the dot product of this force F with the displacement vector D, that is simply given by minus I minus 2J. And remember this F, it is in Newton, and this displacement vector, this will be in meters, right? So this will be simply equal to 2 into minus 1, that is equal to minus 2, okay, plus minus is minus, 3 into 2 is 6, right? Now here the coefficient of KK is 0, so 4 into 0 is equal to 0, right? Okay, so this is minus 6 minus 2, that is equal to minus 8, and the SI unit of work is again joule. And you are already familiar with this negative side. What is the physical meaning of this negative side? If you remember the expression for work, that is given by the dot product of force and displacement. So it is, if you remember, one of the properties of the dot product, it can be positive, negative, as well as 0. Similarly, work done can be positive, negative, as well as 0, depending upon the angle between the force and the resulting displacement, right? So you are already familiar with this negative sign and the physical meaning of this negative sign, because work done can be positive, negative, as well as 0, depending upon the angle between the force and displacement, right? So this is basically the application of this very dot product of the vectors. We are able to calculate the work done by a force in terms of the dot product of force and displacement, right? Now let's try to solve a few more questions regarding the dot product of the vectors. Now let me calculate the angle between two vectors. So let me read one more question from your text. Okay, find the angle between the two vectors where the vector is given are, this is vector A, that is I plus 2J minus K. Let me write the vector A here. This is vector A, it is given by I plus 2J minus K, right? I plus 2j minus k, and the vector b is, and this is vector b given by minus I plus j, this is minus I, okay, plus j, minus 2k. We are supposed to calculate the angle between the two vectors, where vector A is I plus 2j minus k and vector B is minus I plus j minus 2k. Right? Now, how do we calculate the angle between the two vectors? If you remember well, the definition of the dot product of two vectors, this is A dot B, and as per the definition, this is equal to magnitude of A, magnitude of B into cosine of the smaller angle between the two vectors, right? Now, how do we calculate the cos of theta? That will be simply equal, this will be equal to A dot of B divided by magnitude of A, magnitude of B. Now, to calculate the angle between the two vectors, what we require is the dot product between the two vectors and magnitude of the two vectors. This is magnitude of A and magnitude of B. And if you remember well, we can write the position vector R in space like this. This is xi plus yj plus zk. And if you remember, the expression for its magnitude is given by under root of x square plus y square plus z square. Right? I will use the same formula here to calculate the magnitude of A. So, magnitude of A, it will be given by under root of, right, x square, this is xi plus yj plus zk. X ke badle the coefficient of y, that is simply equal to 1. So this will be equal to 1 square, okay, plus 2 square plus minus 1 square. This is how do we calculate the magnitude of a vector, right? So that will be given by, this is 1 plus 4 minus square is plus 1, right? So this is under root of 6. This is magnitude of B. Are you following the steps or not? Simple hai. Now, how to calculate the magnitude of B? That will be simply given by under root of, okay, this will be equal to minus 1 square, right, plus 1 square, okay, plus minus 2 square. This is how do we calculate the magnitude of B. That will be simply given by, this is minus 1 square, that is simply equal to 1. 1 square is 1, minus 2 square is plus 4. Again, it is equal to root of 6. So you can see here, magnitude of A, it is equal to magnitude of B. Now, to calculate the angle between the two vectors, what we require? The dot product, that is A dot B. अगर आपको याद होगा, मैंने ये कैलकुलेट भी किया है, डॉट प्रोडक्ट इन टर्म्स ऑफ द रेक्टेंगुलर कोऑर्डिनेट्स, in terms of the components of the vectors. If you remember well, when we have the vector A and B given in terms of its components, then A dot B is simply equal to, if we have a vector, this is for example vector A, if you remember, if this is AXI plus AYJ plus AZK, and this is vector B, this is simply given by BXI plus BYJ plus BZK. And if we are supposed to calculate the dot product, then what do we write? Simply this A dot of B, it is simply given by AX BX plus AY BY plus AZ BZ. I have already shown this in the lecture dot product of the vectors. So to calculate A dot B here, what I will do, I will simply multiply the corresponding coefficients of I cap, J cap and K cap, and then I will add them, right? So this will be 1 into minus 1, that will be equal to minus 1, okay, plus 2 into 1, that will be given by 2, okay, this is minus minus plus, so this is 2 into 1, that is equal to 2, right? So this is A dot B, it will be given by 2 plus 2 is 4, 4 minus 1 is equal to 3. Now, let me substitute these values here to calculate the angle between the two vectors. So I will write here, this is cos of theta, that is given by A dot B, or A dot B के बदले लिखूंगा 3 divided by magnitude of A, this is under root of 6, and magnitude of B, it is also given by under root of 6, right? So This is 3 divided by root 6 into root 6 is root 6 square. Square और root cancel हो जाएगा. This is 3 divided by 6, that is equal to 1 by 2. If you remember the value of cos of theta from trigonometric table, this is cos of theta is equal to 1 by 2. कब होता है cos का value 1 by 2? At an angle of 60 degree, right? So I will write here cos theta is equal cos of 60 degree. Cos और cos cancel हो जाएगा. So theta is simply equal to 60 degree, or you can write pi by 3, right? Okay. We were having two vectors. We calculated the magnitude of A, magnitude of B, and the dot product between the two vectors. Then the angle between the two vectors came out to be 60 degrees. So the two vectors are inclined at an angle of 60 degree, right? Now let's solve few more questions regarding the dot product of the vectors, right? So far we have calculated the work done by a force when the displacement vector was given, work done by a force in terms of the position vectors, and how to calculate the angle between two vectors, right? Now let's solve a few more questions regarding the dot product of the vectors. And let me read one more question. Okay, if a force F that is given by 5y plus 4j, let me write it here. This is question number 4, and the force F, it is given by, this is 5i plus 4j, where this is, it is given in newtons, right? Okay, a force F displaces a body through displacement. Let me write the displacement d here. It is given by 3i plus 4j. This is 3i plus 4j, where this displacement is given in meters, right? Okay, if a force F 5i plus 4j displaces a body through 3i plus 4j meters in 5 seconds, I mean the time interval here, it is 5 seconds, right? What do I have to calculate? Find the power. Power निकालने के लिए, if you remember well, the definition of the power, that is given by rate of doing work, right? Work done divided by time taken. And if you remember, work is given by the dot product of force and displacement, right? And T is given. So to calculate the power, what we require is the work done. और आपको पता है how to calculate the work done by using the dot product, by using the concept of dot product of vectors. This is simply given by F dot D. So F के बदले क्या लिखूंगा? This is 5i, right? Plus 4j. Okay. Dot. So this is 3i plus 4j, right? Now you remember how to calculate this very dot product. This is 5 into 3, that is 15. I dot I is 1. Okay. Plus 4 into 4, that is 16. J dot j is also equal to 1. 15 plus 16, that is equal to 31, and the SI unit of work is joule, right? Now, how do we calculate the power? Rate of doing work, that is work done divided by time taken. So this is W divided by T. Since the time here is 5 seconds, we have to calculate the power. So let me write here W, that is given by 31 joule divided by T is equal to 5 seconds. So this is 31 by 5. You can write it. Okay, right? So this will be 6.1 joule per second. Do you remember this joule per second? What is it called? What is it called? This is basically watt. Because the SI unit of power is watt, so the power will be equal to 6.1 watt. This is how do we calculate power, right? By using the concept of dot product of the vectors. Now, hope you are getting it. And you are also following the steps. And if you see any question in your textbook based on this very pattern, you can solve those questions from your book, right? Okay, now let's do one more question regarding the dot product of the vectors. So let me read the question first. If 3i minus 2j plus 2k dot 2i minus xj plus 3k, it is equal to minus 12. Find x. We have to calculate the value of x where the dot product between two vectors is given. The two vectors are basically 3i minus 2j. क्या है question? This is 3i माइनस 2j ओके प्लस 2k, ठीक है ना, डॉट 2i माइनस xj ओके प्लस 3k. The dot product between this and this, these are basically two vectors. The dot product is equal to minus 12, right? We have to calculate the value of x. Basically, we have two vectors. Suppose this is vector A, this is vector B, and the dot product between the two vectors is equal to minus 12, right? We have to calculate the value of this very x, I mean the coefficient of j, right? Now, simply I will use the definition. This is just like axi plus ayj plus azk dot of bxi plus byj plus bzk, and if you remember well, that is simply given by ax bx plus ay by plus az bz. So this will be equal to 3 into 2, that is 6, I dot I is 1, minus minus is plus, this is equal to 2 into x, right? So this is plus 2 into 3, that is equal to 6, and it is given, okay, ये दिया हुआ है यहाँ पे, this is equal to minus 12. I mean the dot product of two vectors is given by minus 12. Now let's try to find out the value of x. So this is 2x plus 6 plus 6 is 12. So okay, this is equal to minus 12. ठीक है ना? So 2x is simply equal to, this is minus 12 minus 12. So 2x is equal to minus 24. Simply x is equal to minus 24 by 2. So x किसके बराबर निकलेगा? Minus 12. So the value of x is equal to minus 12. You got it? Simply the dot product between the two vectors is given by minus 12, and we were supposed to calculate the value of x. बस मैंने definition use की, the dot product in terms of the rectangular components, and I solved this very equation to get the value of x, right? Now let's solve a few more questions regarding the dot product of the vectors. You can solve as many questions as you wish from your textbook, or you can have any book with you. Try to solve as many questions as you can by using the basic definition of the dot product of the vectors, right? Now let's do one more. Prove that vector A and vector B are perpendicular to each other, where vector A is given by I plus 2j plus 3k. Question number 6. And the vector A is given by, this is I plus 2j plus 3k, right? Okay, what about vector B? That is given by 2i minus j. This is 2i minus j. There is no k term, so you can write it 0k. What we have to prove? We have to prove that vector A is perpendicular to vector B. Do you remember the condition for the two vectors to be perpendicular? Yes, their dot product must be equal to 0. Let us try to calculate the dot product between A and B. अगर वो 0 निकला, then we can necessarily conclude that the two vectors are perpendicular to each other. So let us try to calculate the dot product of two vectors. So this is A dot of B. This will be given by I plus 2j plus 3k, right? Now I will take the dot product of this very vector with, this is 2i minus j, let me write it 0k here, right? Okay, this is I dot I, that is equal to 1, 2 into 1 is 2, plus j dot j, that is equal to 1, but plus minus is minus 2, okay, 3 into 0, that is equal to 0. So 2 minus 2, it is equal to 0. So what can we conclude from this statement? A is perpendicular to B, right? So the two given vectors are perpendicular to each other. Now let us solve a few more questions regarding the dot product of the vectors. So let me write one more question here regarding the dot product of the vectors. For what value of m is the vector A perpendicular to vector B, where vector A is given by, we have, this is vector A, it is given by 2i plus 3j minus 6k. And vector B, it is given by 3i minus mj plus 6k. Right? We are supposed to find the value of m for which A is perpendicular to B. So when A is perpendicular to B, then that implies that A dot B, it should be equal to 0. We are supposed to calculate the value of m for which A is perpendicular to B. So let me use this very condition, that is A dot B must be equal to 0 for two perpendicular vectors. So let's find the dot product of the two vectors first. So this is 2i plus 3j minus 6k. So the dot product of this very vector, I mean A, with B, that is 3i minus mj plus 6k. This should be equal to 0 if A is perpendicular to B, right? So this is 2 into 3, that is 6, plus minus is minus, this is 3m, minus plus is minus, this is 36, it should be equal to 0, right? So this is 6 minus 36, here it is minus 3m, so this will be minus 30, it will be equal to 0, or I can write minus 3m is equal to 30, simply m is equal to minus 30 by 3, that is m is equal to minus 10. So when you substitute m equal to minus 10, you will get A dot B is equal to 0, that is A is perpendicular to B. So for m equal to minus 10, the two vectors A and B are perpendicular to each other. Now let's solve few more questions regarding the dot product of the vectors. Now let me find the angle between the two vectors. The question is, if the magnitude of two vectors are 2 and 3, and the magnitude of their scalar product is 3 root 2, then what should be the angle between the two vectors? Right now we are supposed to calculate the angle between the two vectors, but here the magnitude of A, it is equal to 2, magnitude of B, it is equal to 3, and one thing more, the magnitude of their scalar product, that is A dot B, it is also given, it is equal to 3 root 2. We are supposed to calculate the angle between the two vectors. Simply I will calculate the angle between two vectors by using the definition of the scalar product. We know this A dot B, it is given by magnitude of A, magnitude of B, and cosine of the smaller angle between the two vectors. So cos theta is equal, this is simply A dot B divided by magnitude of A, magnitude of B. Now A dot B is given, that is equal to 3 root 2 divided by magnitude of A, it is 2, and magnitude of B, it is equal to 3. 3 or 3 cancel ho jayega. So this is root 2 by 2. So let me multiply it by root 2 and divide by root 2 as well. So on numerator I have, this is root 2 into root 2, that is root 2 square, square or root cancel ho jayega, that is 2 divided by root 2. 2 and 2 will cancel out, so this is 1 divided by root 2. So let me write it here, cos of theta, it is equal to 1 divided by root 2. So this is basically cos of 45 degree or pi by 4. So let me write it here, cos of theta is equal to cos of 45 degree. So simply theta is equal to pi, 45 degree, or you can simply write it pi by 4. So the angle between the two vectors is 45 degree. One more question regarding the dot product of the vectors is, prove that vector A plus 2b dot of 2a minus 3b, it is equal to 2a square plus ab cos theta minus 6b square. Let me write the question here. We have to prove that this is vector A plus 2 times vector B. dot, this is 2a minus 3b. We have to prove that this dot product is equal to 2a square plus ab cos theta minus 6b square. Yes, so I will take the LHS of this very equation to prove this. So this is vector A plus 2b dot of 2a minus 3b. Now I will use the properties of the dot product of the vectors here, that is the distributive property. So this is okay, 2 into 1, that is 2 a dot a. So let me write first, this is 2 into a dot a, this is minus 3 into a dot b, okay, plus 4 into b dot a minus 6 into b dot b, right? So this is the first step. Simply I used the distributive property of the dot product of the two vectors. So this is 2 a dot a, it is magnitude of a square, so this is minus 3 a dot of b. Now this is 4. Using the commutative property of the dot product of the vectors here, that is a dot b, it is equal to b dot a. So in place of b dot a, I will write simply a dot b minus 6, and b dot b, it is again equal to the magnitude of b square, right? So this is 2a square, okay, plus 4a dot b minus 3a dot b, this is simply equal to 1, that is simply 1 times a dot b minus 6b square. Now use the definition of a dot b. So this is 2a square plus a dot b, as per the definition, it is equal to magnitude of a, magnitude of b, and cos of theta. This is minus 6b square. So you can see the RHS of above equation, that is 2a square plus ab cos theta minus 6b square. Simply I used the definition of the dot product, commutative, and the distributive property of the dot product of two vectors. Now let's solve the last question regarding the dot product of two vectors. The question is, if vector A is equal to minus 2i plus j minus 3k, and vector B, it is equal to 5i plus 2j minus k, find. Given is, this is vector A, it is given by minus 2i plus j minus 3k, and vector B, it is given by 5i plus 2j minus k. We are supposed to calculate the dot product of a plus b dot of a minus b. Given two vectors are there, we have to calculate the dot product of a plus b and a minus b. Let us try to calculate first a plus b. That is the addition of the two vectors. Rather here, it is the addition of the components of the vectors. Simply we will add the corresponding components of I, j and k. So a plus b किसके बराबर निकलेगा? This is minus 2i plus 5i. So this is, let me write it here first. This is minus 2i plus j minus 3k. So this is plus b 5i plus 2j minus k. Okay, so this is 5i minus 2i, that is simply equal to 3i plus j plus 2j, that is simply equal to 3j minus 3k minus 3k minus 3k minus k, that is equal to minus 4k. This is how do we calculate a plus b, that is the addition of the components of the vectors. Now let us find a minus b. This is vector a minus vector b. This will be simply the subtraction of the corresponding components. So this is a, let me write it, this is minus 2i plus j minus 3k minus, let me write b, this is 5i plus 2j minus k. Okay, so this is equal to minus 2i plus j minus 3k. This is minus 5i minus 2j plus k. Right? So this is minus 2i minus 5i, that is simply equal to minus 7i plus j minus 2j. This is minus j plus 3k plus k. This is minus 3k plus k, that is simply equal to minus 2k. So this is a plus b, one vector, and a minus b, another vector. Now we have to take the dot product of a plus b with a minus b. Let us do it here now. So this is a plus b. इसके बदले क्या लिखूंगा? This is 3i plus 3j minus 4k dot minus 7i minus j minus 2k. And you know how to evaluate this very dot product. You have to multiply the corresponding coefficients of I, j and k and then add them. So this is minus 21, I dot I is 1, rest of the terms will vanish out. So this is minus 3, this is plus 8, right? So this is minus 21 plus 3, that is minus 24 plus 8, that is equal to minus 16. This is the dot product of a plus b with a minus b, right? So these were some of the questions regarding the dot product of the vectors, how to calculate the angle between the two vectors, how to calculate the work done by using the concept of the position vectors and the dot product. Hope you enjoyed today's lecture. Thank you very much.